Welcome back. Not that you went anywhere because it's an online class, but in the last lecture, we worked our way up to short-run labor demand for a single firm. Now we can take this a step further. And in this lecture, we're going to apply the same approach to derive the short-term labor demand for the entire industry, not just for one firm. Now, at first, it would seem like adding the demand curve of each individual firm would be enough to get the market demand curve, but that isn't quite true. In our example with one firm, they have to take the price of an output as given because each firm is too small to influence the market as a whole. And in the vast majority of cases, in the real world, this is true. But when we look at the market as a whole, for the entire industry, how much the whole industry chooses to produce does influence the price of outputs based on whatever their level of production is. So as all the firms in the industry begin to produce more, the price of that product slowly falls, which reduces the price that they receive for the product, thus the value of the marginal product from the additional worker. So now we have another wrinkle added to our model. Each firm in a perfectly competitive market faces a given market price for its output. This means that individual firms are too small to influence the price of the product they sell. So in determining how many workers to hire, firms focus on how much output an additional worker will produce and what that output is worth at the current market price, or the value of the marginal product of labor. If the wage rate falls, firms can hire more workers and as a result produce more output. This is all the stuff we talked about in the last lecture. So again, at first glance, you might think we can just add up the labor demand curves to get the industry labor demand, but that is not a complete way to approach it, because if every firm is increasing their output and increasing their hiring, that's going to have an effect on the price of the product that's being sold. So when supply increases in the market significantly, the more the product is being offered for sale, the price of the product is going to fall. So as a result, the value of the marginal product of labor for each firm is going to decrease because the output produced by each worker is now sold at a lower price. In this case, firms won't hire as many workers as we would expect if we just added up all their demand curves without thinking about this price effect on the market as a whole. Because of the lower output price, the labor demand curve for each firm shifts to the left by just a little bit. This means that at any given wage, each firm is willing to hire fewer workers than before. As a result, the total employment in the industry will be lower than it would be if we just simply sum the original demand curves for individual firms. So the true industry labor demand curve reflects this price effect. So what happens is it ends up being steeper than an individual firm's labor demand curve. This is because, again, the industry-wide increase in output reduces the price of the product, lowering the value that the workers produce. So here in our example, here we have the industry demand curves. This point D to D is what we would expect. Oops, shouldn't have clicked there. If we just summed up all of these individual firm demand curves. But because of this effect on the price, we're going to have a steeper demand curve. So it's going to be like this T to T, where as we start increasing employment from 30 to 56 to 60, all along this line, we're getting less and less money back. So the marginal value of the product of labor is decreasing, hence the steepness of that curve. So we don't want to ignore the effect of price changes. That's the important thing to note here. We can't just sum these up because of the change in prices for the industry overall. Now, let's use these figures to help illustrate what's happening. In the town of Lardo, Pennsylvania, which I've talked about before, imagine a second pizza shop opens up. So now we have two pizza shops in a competitive pizza market. Each shop, both of these, can't influence the price of pizza individually, so they take the prices given. Let's say both shops are willing to hire 15 workers at a wage of $20 and 30 workers at a wage of $10, what we see right here. If we just added up their labor demand curves, we'd expect the industry to hire 60 workers at the lower wage. What do you know? Right here at $10, 60 workers on that demand curve. But if both shops hire more workers and they produce more pizza, the total number of pizzas available in the market increases. This extra supply pushes the price of pizza down. As a result, the value of each additional worker in terms of the revenue that the pizzas that they're responsible for making or increasing the selling of decreases. So instead of hiring 30 workers each, they might hire only 28 workers each. That brings us to 56 here at that $10 wage. So they're again on this steeper demand curve. Now we can also conceptualize a firm's profit maximizing behavior using output instead of looking at workers. So we could say that a firm is willing to produce until the marginal revenue of a product is equal to its marginal cost. Instead of choosing the number of workers based on their value, they choose a production level and hire workers until they reach that production level. Now, from the outside, these two look the same, but the internal decisions are slightly different. But their use of marginal analysis is the same. They're still using marginal analysis here. So this figure illustrates the concept. The marginal cost curve is upward sloping because as the firm expands, the costs that they face begin to increase at an increasing rate. Now, a firm in a competitive market cannot influence the price that they sell their product at. They are what we call price takers selling at the market price. So no matter how much they produce, they sell them at the same price P. And that's why we have this horizontal line here, price P. If that's, $10, if that's $15, no matter how many they produce, what level of output here on the x-axis, it's going to be at that single price. So the firm is going to produce up to the point where the marginal cost, this curve, marginal cost curve, equals the output price. Because output is a straight line, because no matter how many units they sell, it's going to be the same price. The marginal revenue they get is going to be at P, that price. So if it's $15, they sell another unit, they get $15. So where these 2 points cross, where the marginal revenue equals the marginal cost, or the price equals the marginal cost, that is where the firm is going to maximize their profits. So this is represented by the output level Q star. If a firm tried to produce their, increase their production, I'll say above Q star, so if they try to be over here, look here, the output price is below their marginal cost. So they would end up losing money from their increased production. So they're not going to want to produce out there. Or if they do produce out there, they're not going to want to do that for very long once they realize that they're losing money. Now, in the short run, firms make decisions primarily about how many workers to hire, since they can't easily change the amount of capital they use, things like the size of the building or the equipment that they have. Those are fixed for the short run because that's how we define the short run. But in the long run, firms have more flexibility. They can adjust both labor and capital to find the most efficient way to produce goods and to maximize profits. This means firms now face a more complex decision in the long term. It's not just about hiring workers at a given wage. They have to consider how much capital to invest in, so things like machinery or technology that makes workers more productive. Firms need to figure out the best combination of workers and capital that allows them to produce their goods at the lowest possible cost while meeting demand. To help us understand how firms make these decisions, we use something called isoquant curves. These curves show the different combinations of labor and capital that produce the same level of output. For example, a pizza shop might be able to make 100 pizzas in a day by hiring more workers and using less equipment, or by investing in better ovens and hiring fewer workers. Both of those can result in them making 100 pizzas a day. So the isoquant curve helps us see all the different combinations of capital and labor that firms can use to produce the same amount of pizza or any product. So an isoquant, which is a terrible name, if I'm being honest, if we want to understand this, shows the combination of labor and capital that produce the same level of output. So in this example, we have two inputs in the firm's production function, labor and capital. Now this should look and sound a little bit familiar. Isoquants are to firms what indifference curves are to individuals. So along an isoquant, let's look at Q0 here. At each point or each combination of employment and capital, firms can produce the same level of output. The only thing is how much labor do they want to put in versus how much capital they want to put in. So if a firm wants to produce 1,000 units of a product, they can choose to use a lot of capital and a small number of workers, somewhere up here, or they could choose to use a lot of workers and a small amount of capital, which would be down here. An example is fast food restaurants. As wages rise or say minimum wage laws rise, some of them are opting to go to self-serve kiosks in order to take orders. This is an example of firms choosing to use more capital and fewer workers. But then in your rural, lower wage areas, Fast food restaurants like McDonald's tend to have more workers and less self-serve options. Either of these combinations can be used to achieve the same level of output, but they end up being different for the firm itself. Again, more capital or relying on more labor. The isoquant Q0 is the initial curve, which represents one level of output. So we could say that's, say, 1,000 units of output. Moving to isoquant Q1 would be increasing the level of output because it's farther away from the origin. So maybe instead of 1,000, it's 2,000 units. If an isoquant is further in on the graph, closer to the origin, so say if it would be down here from Q0, that represents a lower level of output. So for example, Q0 might represent producing 50 pizzas per day for your pizza shop. An isoquant further away, like Q1, might represent producing 100 pizzas per day. And the further an isoquant is from the origin, the more output it represents. When if a firm moves to a higher isoquant, that means that they become more productive. Either they're using more inputs, so more workers and more capital, or by finding a more efficient combination of inputs. Now, isoquants have four familiar properties, which are just like indifference curves. They're downward sloping, they don't intersect. Higher isoquants are associated with higher levels of output, and they're convex to the origin. These are just like the characteristics of indifference curves. So we've just discussed isoquants, which show all the combinations of labor and capital that produce the same level of output. But while isoquants tell us how much we can produce, they don't tell us how much it costs to produce that level of output. In the real world, firms don't just want to know what's possible. They also want to know how to minimize costs, because that's a serious consideration for firms operating in a market context where they have a hard budget constraint. This is where ISO cost lines come in. Just like ISO quants help us understand the trade-offs between labor and capital in terms of production, ISO cost lines help us understand the trade-offs between labor and capital in terms of cost to the firm. An ISO cost line shows all the combinations of labor and capital that a firm can afford given a certain budget. So if they have $10,000 to spend in a month, how much capital and labor can they afford? And all the different combinations of them. So a restaurant could hire 5 workers and buy 1 oven to cook their food, or hire 3 workers and 2 ovens to make their food, and result in the same amount per day. But these different combinations of labor and capital can cost different amounts of money. So the shop wants to choose the combination that not only allows them to make the desired numbers of pizza, but also to minimize their costs. A firm needs to consider not only how many workers and ovens it needs, that's the ISO quant, but also how much it costs to hire those workers and to buy those ovens. That's the ISO cost line. By combining these two together, the firm can decide on the most cost-efficient combination of inputs. So here's an example of 2 potential ISO cost lines for any firm, because it's much easier to visualize this and put it on a graph than it is for me to just sit here and explain it. All combinations on each line are equally costly. So every point on the ISO cost curve CW here, or C0, excuse me, has the same cost. Now the ISO cost line C1 out here has a higher cost at every single combination. So a firm that tries to minimize costs, which is most firms, would prefer to be on line C0 rather than line C1 because it represents lower costs to them. Now the point on the x-axis down here represents one extreme. This is a firm that hires all workers and uses no physical capital. The y-axis up here is the other extreme, where the firm uses all capital and not a single worker. They're completely automated. Now, almost all firms rely on some combination of workers and capital, lying somewhere in here between the 2 axes. The slope is the trade-off, or the ratio of the price of capital to the price of labor. It shows the relative costs of these 2 inputs. If the slope is steeper, that means a firm can trade off fewer workers for more capital. It means that labor has become relatively more expensive compared to capital. So this firm is likely to try to substitute cheaper inputs, so capital, for more expensive ones, or labor to minimize the cost, while still producing the same level of output. So let's put these together and see just how these 2 concepts work in practice for a firm. We're looking for the point where the firm can reach a particular isoquant, a specific level of production, while staying on the lowest possible ISO cost line. which minimizes the cost. So instead of being out here at C1 at the higher cost, the firm would prefer to be down here on line C0, as close as possible to the origin. So they're going to produce where the ISO cost line is tangent to the isoquant curve. So at this point, the firm achieves their cost-effective production, the lowest possible cost to reach that level of output. Firms want to choose a combination that allows them to produce the desired level of output efficiently. ISO cost lines represent, remember, all the combinations of labor and capital that they can afford given its budget and the price of labor and capital. The slope on our ISO cost line depends on the relative cost of labor and capital. So the firm wanting to minimize costs while producing the desired level of output is going to produce, again, I want to drive this home, where they are tangent to each other, where there is just one point that touches that line. At that point, the firm is getting the most output for its spending using the most efficient combination of labor and capital. Okay, and your textbook talks about this a little bit. I don't want to go into too much detail on it, but the slope of the isoquant represents what they call the marginal rate of technical substitution. What that means is how much capital the firm can substitute for labor while keeping output constant. So the slope of the ISO cost line represents the ratio of input prices, so wages for labor and cost for capital. At this optimal point, in this example, point P, these slopes are equal, meaning that the firm is balancing the trade-offs between labor and capital in the most cost-effective way. So you guys are going to be more tired of this pizza place example than the St. Francis students that had nowhere else to eat in town. But imagine a pizza shop that wants to produce 100 pizzas per day. They can do this with different combination of workers and ovens. The shop doesn't just want to produce 100 pizzas. That is one of their concerns, is to hit that level of output. But they want to do so in the cheapest way possible. They do that by finding the point where the isoquant for 100 pizzas is tangent to the ISO cost line at their lowest possible cost line. So they can determine how many workers to hire and how many ovens to invest in while minimizing their overall costs. Remember, in the short term, it's all about the marginal analysis of deciding to hire that next worker or not. It's a little bit different in the longer term, where they have that decision, all right, how much capital do I want to invest in? How many workers do I want to hire? They have more choices at their disposal. So profit maximization involves two separate things: maximizing revenue and minimizing costs. Maximizing revenue, let me back up. Maximizing profit requires minimizing costs, because by producing output at the lowest possible cost, the firm can maximize the difference between its revenue and its costs. So both sides are important. You want to maximize revenue and minimize costs. Focusing too much on one or ignoring the other will result in the firm wasting money, or so their costs are too high, or leaving money on the table because they're not maximizing their revenue side. So firms have to carefully consider their costs. In the long run, this is both labor and capital. In the short run, we're just talking about labor, but in the long run, it's both. So to do so, the firm has to choose the least cost combination of capital and labor. Firms actively compare costs, and when the relative prices between them change, so if labor becomes more expensive or capital becomes more cheaper, they'll substitute between the two. So if wages rise, the firm might buy more capital and rely less on labor. Graphically, the choice with the lowest cost is where the ISO cost line is tangent to the isoquant. At the least cost point, the rate at which the firm is willing to substitute labor for capital, the marginal rate of technical substitution, is exactly equal to the rate at which they can substitute labor for capital based on their budget. This balance is what ensures costs are minimized. You know what? It's already hitting at about 20 minutes, this lecture, so I think I'll stop here, and we will pick up the long run demand for labor in the next lecture video.